Hello everyone, thank you for joining my session. My name is Michal Brygidyn. I work as a cloud security architect at Zibia in Poland. I'm AWS ambassador and AWS community builder, but after hours I wear a white hat and I do security research looking for leaking data in different places using different search engines like Shodan, Census, Binary Edge. Today I want to share my research with you. I will show you how I can get admin access on your AWS accounts. First scenario is very, very easy. Because you just need to find a website where someone left a comment or a piece of JavaScript. It can look like that. A simple website and a comment from one developer team to another team. So yeah, this is a configuration for the AWS profile for the CLI. And interesting note, remove before production release. So yeah, this is the perfect way of leaving documentation for another team. And this is enough to get admin access because this was IAM user with administrator access policy attached to it. That easy, admin access on that account. What went wrong here? Sensitive data left in the code. There are other ways to create documentation for the team. There are other ways to pass credentials, keep them involved, share them another way, but do not leave this sensitive data in the code and in the repository. Next scenario, GitHub. Do you use GitHub? Okay. So, yeah, for GitHub, there are many public repositories with interesting data in them. Usually AWS quickly finds the file that you just pushed with your access and secret keys, and then they add a policy to your user preventing anyone from using that. But you don't need access to these credentials to access someone's AWS account. There are other ways. I found many repositories with sensitive data, but this one was interesting because there was a config file with values of these variables encrypted. So yeah, these are examples of multiple repositories and files in these repositories, public repositories. You can find passwords to email accounts, to databases, anything. Recently, also Jupyter notebooks contain sensitive credentials to clouds, to other clouds, or to databases, and people just leave it there. But going back to this repository, there was a decrypt function in the same repository with the secret key hard-coded in it. After that disclosure, I asked the team, why? Oh, that's the only place where we use that secret key, so why keep it elsewhere? Yeah, it's easier for me to decrypt your variables if I have everything in one repository. So I decrypted it and found Office 365 credentials. How do I know that these are Office 365 credentials? SMTP office365.com, so very easy to identify where to use these credentials. And I logged into Office 365. This was a regular user with all apps available to that user. So I was able to talk on Teams to anyone in the company, including C-levels. And I also checked SharePoint, because if there is MS Teams enabled, then there are some teams that are public. But public in Office 365 means public for anyone in the company. But hey, I am in the company, I just logged in. So I checked SharePoint, and there were public repositories, the public teams. The one team contained files created by support guys, admin guys. They created a guide how they installed Atlassian products, including Jira. And this was the full guide, step by step, last step. And now we created admin user with login and password. Okay, thank you. Let's try that. So I logged into Jira, And then I checked projects in that Jira. And there were many projects with AWS in the name. So I checked one. And there was a task to create access and secret key for a team to do something. And they asked for admin access because, hey, we will work with IAM resources, so why limit it to just IAM? If you have IAM access, you are admin. So this was it. In the comment, they posted this access and secret key in the comment of that task. That easy. Oh, maybe not that easy, but still, there are better ways to pass this kind of information. What went wrong here? First of all, hard-coded sensitive data. Once again, do not leave anything important in your files in repository, because when I get access to your repository, I will extract it. And also, other team members that shouldn't be allowed to access some systems in your project will have access to this file in repository, and they can just log in there. Also, bad tool selection. They decided to use public repository on GitHub for that project. Okay, variables were encrypted, so someone knew something, but still they decided to use public repository because, hey, we don't know what else development teams are using. We are support, we don't use your tools. And risky credential sharing. So when you create a guide that you build something, do not leave credentials there. If someone asks you to document every step, creating user is not a step that's worth documenting the same file as previous steps. And yeah, lack of security awareness. This team in SharePoint was public for the company, so anyone in the company was able to look at these files and extract whatever they wanted from it. Sometimes I noticed that people are using their own users, AD users, in different scripts. This is also a bad idea because then I will be your user. If I get access to your username and password, I can log in and I can pretend to be you. I can talk to anyone. I can see your history of chats on Teams, anything. I will get access to your Outlook and your emails. Instead, use service accounts dedicated to your tool only. Then, next scenario, we have Symfony Profiler. Do you know Symfony? That's a PHP framework to build apps. And Profiler is a development tool that helps you build these tools and helps me hack these tools. Because Symfony Profiler, when enabled and publicly exposed, gives access to server configuration, gives access to environment variables for the app, and also gives access to a history of all requests to that app, including login requests, post requests with username and password. Examples here, environment variables, and already access and secret key for AWS, but only S3. I don't want only S3, I want admin. So going deeper, from request, I found a request to login endpoint, login and password in plain text. Something changed in recent versions, but if the password is not in plain text in this post parameters field, there's a raw request string at the bottom of the page with plain text password. So going back here, I logged in to an internal app. It was a dev environment because the profiler was enabled on a dev environment. But hey, it's only dev.example.com. What will happen if I remove dev. and log into example.com? It works. So I just got access to production environment of some company's internal app. And there was a dashboard with many icons, other internal apps, and SSO. Whenever I clicked an icon, I was just logged into that app, including webmail. There was also a CRM, but I don't need data. I just need admin access on AWS. So webmail. Quick search, AWS. Yay, trusted advisor emails and invoices. So this may be a root user email. It's worth trying to log into that, but we don't have password, but we have email and access to inbox. So maybe try to reset the password. And yeah, it works, no MFA. So I reset the password for that account, logged in, and I was a root user of that account. But it was a jackpot, not only that account. It was the organization management account. So instead of admin access to one account, I just got access to 40 accounts or something like that. So easy way, starting from the dev environment of some app. What went wrong here? First of all, production data used on non-production environment. It doesn't matter if it's just the same password for admin user or is the whole database. If you use the same password for admin users on non-prod and prod, then when I get access to your password on non-prod, I will just log into your user on prod. So it's a good idea to have unique passwords on different environments. And also with the data, if I was looking for a data, then the production data would be valuable. But you know your data types, so you can generate a dev database for yourself. You know the size of your production database, you know how it looks like. Just generate it. Do not dump production and use it on dev. Also, when I accessed that single inbox, I noticed other services, emails from other services as well. They use that single inbox, that single email address to sign up for Datadog, for AWS, for Cloud Health, I guess. Many services there. So with access to single inbox, I was able to get everywhere. And no MFA. That's one thing that if you need to remember one thing from my presentation, use MFA everywhere. It makes my life harder. Next, Kubernetes. Who knows Kubernetes? Who uses Kubernetes? And who is 100% sure that your Kubernetes is secure? Okay, this one starts with publicly exposed Kubernetes control plane, Kubernetes API. If it's exposed, then anyone can access it using just a web browser, nothing else, just a web browser and URLs after random IP. And when you get access to that, you can extract secrets. These secrets are base64 encoded, so why not to decode it instantly? Then we have config maps in plain text, also easy to print it in a readable way and extract anything from that. And a list of pods with all configurations for your pods. It's very easy. But also you can configure kubectl and do whatever you want with all these pods on that cluster and all this information. My tool extracts all this. It works in a way that I ask Shodan or Census, hey, give me all publicly exposed Kubernetes control planes. And I get the list of IPs. Then the list of IPs is sent as a file on S3. When it lands on S3, a Lambda is triggered and grabs the file and sends separately each IP as a different message on a queue. Then from SQS, another Lambda, or well, a lot of Lambdas are triggered, and these Lambdas are trying to find what's there and process the IP. And then another one that reads my reports and tells me, oh, you need to focus on these 4 at the very beginning of your research because there is raw meat inside. As you can see from config maps, I already have access to some accounts. Oh, it's not working here. Already access to credentials, to email configs or database access, but we need more. So from secrets, I was able to extract credentials giving me full access to S3 on that account. But also, there were credentials to Jenkins. Do you know Jenkins? OK, perfect. Jenkins is the automation server, and Usually, when it builds your resources on your cloud, Jenkins has admin-like access. So now we need to access that Jenkins app. We have login and password, but we don't have access to the app. And there are two ways. First, start with jenkins.example.com, because in many cases, companies just expose Jenkins publicly. But if not, you can use kubectl to forward port 8080 to your local host and access localhost 8080, and this Jenkins will pop up. So just log in using credentials found from in a different place, and you're in. When you're in Jenkins and you are admin in Jenkins, you can do whatever you want. For example, you can check all jobs configured there and see if anything is talking to AWS CLI. If it is talking to AWS CLI, you already know that there is a configuration for that somewhere. So either there is a profile for AWS or there is a role on this Jenkins, and you can extract temporary credentials from metadata. There are also other interesting places in Jenkins, like build log, sometimes exposing sensitive data, or Jenkins credentials. If you think that Jenkins credentials are safe for your credentials, you're wrong, because if you're admin, there's one liner to decode all credentials. And if not, you can create a new job printing values of each credential there. In this case, there was, for example, access to GitHub, but it wasn't interesting because I found AWS CLI calls in one of the jobs. So I decided to use kubectl to exec into the pod to start bash there. And this pod was using a role with admin access on it. What went wrong here? Public resources. First of all, if you have your Kubernetes cluster exposed, control plane exposed, it means that either you don't know how networking works in AWS, or you made a mistake and nobody noticed that, or you don't have your non-prod environment in scope of penetration testing. These are the responses from the companies when I asked why. And also, I don't know why these control planes just let me in. I'm not a Kubernetes expert. I just know how to exploit that. And there are hundreds of exposed control planes. If you know what you're looking for, you will get the whole list. And every week when I run my script, I get another IPs. And also, sensitive data in there is unencrypted. You can encrypt your credentials stored there and use another channel to decrypt it on the fly when needed. So if there is a way to secure your data with additional layer, please do it. It will be more work for me to access your passwords. And then principle of least privilege. That's the second thing that I want you to remember after my presentation. Do not give admin to all. Think about the real need for that tool or for that person. If that tool just needs to read one file from one S3 bucket, it doesn't need full access to all S3 actions. It just needs access to the single bucket and single file. And sometimes CI/CD tools are the weak point where I can get in and access your cloud. Because if you use your automation tools to build your cloud resources, these tools have admin access. So you need to protect these tools even more than your app. Because either I can create a new job and create malicious resources on your cloud, or I can access your repository and then push my code to the repository. The repository change will trigger the automation, and still my malicious resources will be created on your cloud. And this can be my backdoor there. There are also more ways to access AWS. Slide's still not ready. I created this slide like a year ago. Let's start with outdated software running on cloud servers. And this one is my favorite Atlassian Jira. Version 7.3.3, but there are many versions that are vulnerable. There's a problem with OpenProxy in OAuth plugin. So this is the same Jira instance. I just use the URL with a metadata endpoint to extract temporary security credentials for that server, for that EC2. And I don't know why, but it was admin. Then we have admin credentials logged during the installation. When I was asked by one of my customers to do the audit of their AWS environment, I was granted read-only access. So I checked many places and found almost nothing, but then I decided to go to CloudWatch. In CloudWatch, they had a log from Jenkins installation. And also at the end of that log, after Jenkins was installed, there was a log record. And this is login and password for Jenkins super admin user. Perfect. Because Jenkins was public for that company, so I was able to just log in and give myself admin permissions. Then we have misconfigured virtual hosts with directory indexing enabled. If you use Apache or Nginx, you can have default vhost on your IP, and then you create your own vhosts for your domains. But still, the default one will point to one directory, but your domain-specific vhost will point to a directory inside that directory. So if you just go to IP, you will see this. And there's one interesting file, .env, or more interesting files, but this .env file usually contains what I am looking for. Then we have debug pages and connection strings. As an example, Python Django. This one is doing a good job masking almost all sensitive information, but there's Celery broker URL that consists of access and secret key for the SQS connection string. So in many cases, these credentials not only gave me access to SQS, but other services as well. And that's all from my cloud hacking scenarios, and just a small teaser of my next presentation for this year. Backdoors and my ideas for backdoors. I divided it to different groups. First group, servers, and this one starts with either creating public EC2 with admin permissions, if I have admin access on your account, or I have access to your EC2 service, then I can create a public server which I can use to connect and to have access to your AWS account using a role, or I can create a local user on any of your public running EC2s. Or I can create IAM user, or I can create additional access key for existing IAM users. So please don't use IAM users. There are better ways to connect to AWS. I can modify trust relation and trust policy, so my role from another hacked account will have access to your role on your account, and you will not know that I am using that role. I can create new policy version, giving me more access for anything that I have access to. For example, I have access to EC2, but it's not admin, it's just EC2 with access to S3, so I can modify the IAM policy, and now I am admin. Or I can replace the role for the service. Oops. Yeah, and the last one, services. Old slide, new slide. This was the right one. Then we have networking, and for networking I can modify security groups to add a rule allowing my IP to access your resources. I can create a VPC peering between my VPC on another hacked account with your VPC, or create a transit gateway attachment. I just need to share your transit gateway with my account, and usually that's it, and I need to create a route for that. For services, if you don't use Identity Center, AWS SSO, I can create one for you with my user in it. Then we have code pipeline, code build, and a connection to GitHub. I can create a connection to my GitHub from your code pipeline, and whenever I push a change of my Terraform in GitHub, this will be triggered, and code pipeline will be triggered. It will start code build, and my resources will be created in your account. Or I can create a Lambda with function URL and trigger it whenever I want, and the Lambda can, for example, rebuild my previous backdoors if you find them and remove them. And a bit of hide and seek. For self-healing of my backdoors, I can, for example, use Event Bridge, and I can either create a cron there, or I can look for specific API calls when you delete one of my backdoors. It can trigger Lambda to rebuild that. For step functions, I can run step functions in a loop, running Lambda to rebuild everything. Then I can create a cron on your EC2s to also rebuild something. And with CloudTrail, CloudTrail sends logs to S3. S3 triggers Lambda. Lambda says, oh, there was a change in one of your backdoors, recreate. For detection prevention, I have power user because I am full. This one means that some tools mark risky roles or risky users. By risky, they only mean users with administrator access policy attached. So instead of administrator access, use these two, and you're good, because this is the same as admin access. Same context. Whenever I have access to your EC2s or your Kubernetes cluster, I can extract metadata and use this metadata on use these credentials from metadata on my Mac to communicate with AWS API, but then GuardDuty will find me, because these were credentials created for the EC2 or for the Kubernetes used somewhere else. So instead of that, I can just talk to AWS from your EC2. And it's good to do it in your office hours, because it will be lost in all this noise from all your legal actions. And that's all. Thank you.